Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to look for tangent lines at the pole. Okay, so our polar equation is r equals 2 times 1 minus cosine theta. And again, we're going to find the tangent lines at the pole. So for that reason, we need to know what the slope of the tangent line is at the pole. So to do that, you have to check the very first derivative, dy over dx, but unfortunately this is not given in the form of y equals f of x, so we can't use the old formula dy over dx, like the very first derivative of the function for this purpose. So we need to have an alternate formulation of dy over dx. That's in fact what we're going to use. And to give you a heads up a little bit, so this is a cardioid, and we're looking for the tangent line at the pole. So this picture hopefully would give you some idea about what to expect for the rest of the video. All right, please have your graphing calculator ready at this moment and put it in the polar form, and let's get started. All right, let's look at the tangent. Let's try to find the tangent lines at the pole for r equals 2 times 1 minus cosine theta. We can go ahead and, well, by the way, where's the pole? The pole is like theta equals 0. Okay, let me just write that down here. And we can go ahead and look at the formula, the slope formula in the polar form. So we're talking about theta equals 0 case, okay? And in our case, r equals 2 times 1 minus cosine theta. This is our f theta. Okay. Well, we are going to look at dy over dx at theta equals 0. Okay, and that's going to be in fact this fraction here. But let me just tell you what's going on here. So when you plug in 0 for theta, no matter what f prime theta is, okay, so you have f of 0 cosine 0 plus f prime at 0 times sine 0. And this is minus f of 0 sine 0 plus f prime 0 cosine 0. Okay, we can in fact go ahead and find f prime real quick. Let me just decide where I can write that. Let me just write it right here. F prime theta is going to be the derivative of 2 times 1 minus cosine theta, and that is 2 sine theta. Okay, let me just simplify this, but first observation, sine 0 is going to be equal to 0, so these are gone, okay? And therefore I have cosine 0, f0, and in the bottom you have f prime 0, f prime at 0, cosine 0. Look what's going on here. F prime at 0 is as well equal to 0. Okay, and so is f0, right? Because if you look at f of 0 here, okay, it's 2 times 1 minus cosine 0, which is 2 times 1 minus 1, and that's also 0. So in fact, interestingly, all of these guys are 0, okay? So you're running into 0 over 0, which makes the slope undefined, okay? Defined. All right, this is a very interesting case. And you can graph the given function like 2 times 1 minus cosine theta and get some visual out of that and see why the slope is not defined. Okay, so here we go. As you see, I can't find what the slope is here. So it's like a cusp happening here, right? We don't know exactly what the slope may look like. So that's why the slope is undefined. So for this cardioid, okay. So make sure you observe this by yourself, that the slope is undefined. Slope is undefined because dy over dx becomes 0 over 0 at theta equals 0. All right. So this was a short video. Thanks for watching. I'll see you in another video. Bye.